If we're going to find the derivative of this problem set in the product and quotient rules section, all of these are something we need to find the derivative for. I took a moment and I drew up all the rules we know so far. There's only 5 of them after all this work. We know the power rule, where if I have a polynomial, we subtract the power by 1 and bring it down. The derivative of e to the x is e to the x. The conjugate rule isn't even a derivative rule, right? It's just a reminder that you can FOIL out 2 terms that are the same but contrapositive like that and have no middle term here. Now the product rule we just learned in the lecture series, but we're going to practice it here. So if that's unfamiliar, don't even worry about it. You just remember that 2 multiplied functions, their derivative becomes u prime v plus v prime u. And the quotient rule is actually the same as the product rule, but the algebra has been rearranged for us and then solved. So this one, again, u prime v and v prime u, but it's a subtracted, and then it's divided by v squared. So it's a plug-and-play situation today. No big deal. Start with the first one. I see functions of x multiplied, so I'm thinking it's going to be product rule. If I was to take x cubed plus 2x e to the x and actually expand it out, you would get like an x cubed e to the x, and these are multiplied, so you'd have to product rule this and product rule the next one. So I'd rather only do 1 rather than 2. So the first term is going to be our u, and our second term is going to be a v term. So u is x cubed plus 2x. Nothing weird about that. V is e to the x. And we need to know u prime, which is going to be 3x squared plus 2. And v prime is e to the x. These are power rule, remember, right here. You better remember that. We've done a number of problems, and of course the exponential rule. So nothing weird. To do the product rule, we know that p prime is u prime v, so 3x squared plus 2 times e to the x plus v prime e to the x times u. X cubed plus 2x. Okay, so let's expand it out. We take an e to the x out, and we're going to get a 3x squared plus 2 plus x cubed plus 2x. Heck, we can't even reduce that at all. We could rearrange it. But this is the answer. Right there. Because we have an x cubed, squared, x, and a regular term. We can't combine any of those. That's the answer right there. So number 1 is done. Let's come to the next one. Y equals x over e to the x. Well, this looks like a quotient rule, but I want to remind you that you can write this as x e to the negative x and use a product rule, which is less work. If you notice, less work is good work. So I'm going to use the product rule for this one because I'm a smarty farty. Okay, so what's y prime? They call it dy dx because we're taking the derivative of y with respect to x is equal to u prime v plus v prime u. So what's u? U is the first term, x. V is the second term, e to the negative x. Not e to the x, e to the negative x. So u prime would be 1, and v prime is going to be negative e to the negative x. Okay? The negative has to come down. Now, let's write it out. U prime, 1, v, e to the negative x, plus v prime, negative e to the negative x, and u is x. So, if we take an e to the negative x out, what do we have? 1 minus x. And then I can move the e back down here, and this is our answer, 1 minus x over e to the x. Shall we confirm? Shall we do the quotient rule? Should we see if it comes with the same answer? I'd sure like to know. Our u term is going to be x. Our v term is e to the x, because it's in the denominator for the quotient rule, not negative x like before. U prime is going to be 1, and v prime is going to still be e to the x. So the quotient rule says u prime v, so that's 1 times e to the x minus v prime e to the x times u, which is x. And that whole thing is going to be divided by v squared, which is e to the x squared. Okay, another way to write that is e to the x times e to the x, right? Or even easier is e to the 2x, which is how I prefer to write it. But just in case you forgot, those just add together. So let's take an e to the x out here, and we get a 1 minus x on top. This is all over e to the 2x. Well, of course, this cancels with one of these, and you get 1 minus x over e to the x. Same answer as with the product rule. So if you're able to bring something up from the denominator, you'll find the product rule is a lot more forgiving and a lot faster. That's how I like to roll. Zit, 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 zit. Okay, next one, g of x. We know it's going to be quotient rule. Look at that thing. I can't bring that up. So my u is going to be 1 plus 2x. And my v, the denominator, is 3 minus 4x. U prime is going to be, well, there's no derivative of 1, so that's gone. The derivative of 2x is just 2. And v prime is negative 4. This might not be as bad as it looks, right? So u prime v, that'd be 2. That's u prime times 3 minus 4x. That's v minus v prime, negative 4, times 1 plus 2x. And that's all going to be divided by 3 minus 4x squared. So to start, let's expand. We get 6 minus 8x. And I'm going to be careful about how I do this. So I'm going to write minus negative 4 minus 8x, just to make sure I don't miss my pluses transferring out there, and then over 3 minus 4x squared. So we get 6 minus 8x plus 4 plus 8x over 3 minus 4x squared. Now I notice plus 8x minus 8x. So our answer is going to be 10 over 3 minus 4x squared. That's the derivative for that one. Who's next? This one with the square roots is a little scary, but I noticed something. This term looks a lot like this term. I am thinking we can use conjugates for that. So I'm going to write h of u is equal to u minus the square root of u and u plus the square root of u. But look, this is a minus b times a plus b. We're going to get our conjugate as a squared minus b squared, aren't we? So what's a squared? That's u squared minus the square root of u squared is u. So u, this is what we have. So h of u is equal to that. So we can take h prime of u, and we just do the power rule, 2u minus 1. That's done. That's the easiest one on the list. It looked hard, but if you know your conjugate rule, only 5 rules so far, even with the product and quotient rule being kind of scary. I just want to point that out. Let's try the next one, JV. Oh my goodness. Okay, this one we're not going to get so lucky, are we? But let's see what happens. V cubed minus 2v times v to the negative 4 plus v to the negative 2. Can we FOIL this out? I don't see why we can't. Let's try foiling it out before we do any kind of crazy rules. V cubed times v to the negative 4, you add them. So that's going to be, I don't even need to put it in parentheses, v to the negative 1. And then this one, it's going to be minus 2v to the what? That's v to the 1. I don't want that underneath there. There we go. Minus 2, that's v to the 1 minus 4, so that's negative 3. And then these terms here, v cubed minus 2 is just v, right? Because when they multiply, you just add their exponents. And then, what am I missing here? Which one did I not do? The negative 2v That's going to be to the negative 1. So that's going to be minus 2v to the negative 1. I think I expanded those all correctly. Be careful, though, and double check me on that one. So let's put these in order. That means that we're going to take a derivative. So let's derivative this. And we would get negative 1v to the negative 2 plus 6v to the negative 4 plus 1 plus 2v to the negative 2. So far, so good. I want to combine these because I can. Negative 1 plus 2, of course, is 1, so that's going to be v to the negative 2 plus 6v to the negative 4 plus 1. That's our answer right there. That wasn't so bad. So in this case, because everything was connected by simple addition after we FOILed it out, you can just use your power rule. No quotient rule or product rule necessary, but you can do it if you want. It's just too much work. It really is. You got to be able to get through your test quickly, you know. It's not just about being able to do a rule. It's about knowing which rule to do. And you definitely want to do the power rule and the e to the x rule in your conjugates whenever possible. Those are fast. And they're correct. They're correct. Okay, last few questions here. G of x equals x to the 1/2 e to the x. That's a product rule. Our u value is x to the 1/2. You might call it root x, but I don't. E to the x. U prime, well, we can power rule. X to the negative 1/2. And v prime, still e to the x. You know this rule. So u prime v plus v prime u for our product rule. It's a product. They're multiplied. I'm not doing anything particularly special. 1/2 x to the negative 1/2, that's our u prime, v, e to the x, plus v prime times u, x to the 1/2. Take an e to the x out, and what do you get? 1/2 x to the negative 1/2 plus x to the 1/2. So if you want to write this out for your teacher, try and look smart. E to the x times 1 over 2 rad x plus rad x. And just stick it right back in there. You see this to the negative 1/2 is what brought it down into the denominator, right? I hope you know that. That was back in algebra. I can't do every step of everything and get through these quickly, so you're going to have to fill the gaps here with what you know. Okay, two more. This one is clearly a quotient rule. I don't know how we would bring that up to the top. So we have e to the x over 1 minus e to the x. Let's decide what our u is e to the x, and our v is 1 minus e to the x. Shocking. U prime is e to the x. V prime is, this doesn't exist as a derivative part, that's just gone, so that would be negative e to the x. Same thing. So quotient rule says right here, still barely on screen, u prime v minus v prime times u all over v squared. Okay, so should we take an e to the x out? See what happens. There's a 1 minus e to the x. And let's say I took this one out just to keep it easy. That would be a plus e to the x. So these actually subtract away from each other, don't they? Those parentheses weren't necessary, and this is a times 1. So I think we actually just get, this whole thing is canceled. And we just get e to the x over 1 minus e to the x squared. And that is the correct answer. Notice how similar this is to the original. You just square the bottom in that case. Don't rely on that, but it's fun to spot that. And maybe after your PhD you can do that reliably, but I wouldn't. Last one. You can do this. It's the last one. Okay, g of x is equal to x squared minus 2 over 2x plus 1. What's our u term? That's the numerator, x squared minus 2. There's our v term, 2x plus 1. We can take the derivatives of these by themselves, right? Nice and easy. 2x, no big deal. V prime here is just 2. And it's quotient rule. It's quotient rule, baby. It's Chinatown. 2x u prime v plus v prime. Oh, not plus. Come on, you guys got to catch me on that. Minus v prime times u, x squared minus 2. And that's all going to be divided by 2x plus 1 squared. We'll see what we can do with that later. They don't seem to have a ton in common, but I'm going to FOIL it all out and we'll see what we get. Why not? So 4x squared plus 2x minus 2x squared plus 4. And this is all over that numerator. I'll write it in a second. But I want to clean this up a little bit. We have some x squareds to put together, so we get a 2x squared plus 2x plus 4. What can I take out of this? Let's take a 2 out of it. X squared plus x plus 2. And that whole thing is going to be divided by our 2x plus 1 squared still. Let's just remember that. So I think we can factor this, 2. And I think it's going to be x plus... Actually, I don't know that we can factor that. I don't think that we can factor that. I don't know of what adds up to 1 and multiplies to 2. We would have to use complex numbers for that. So I believe this is going to be our answer right here. Right here. If I FOIL this out, we might factor the 2 out. You might want to take a look at that. But otherwise, this is the problem set for our first attack at product and quotient rules.